Lesson 4, rotation. So first of all, we've already talked about how rotation translations look. We just haven't specifically went over where the lines and how points move among a rotation. Now there's not a set rule for every single rotation, so I'm going to give you the ones that are easy to do, and we'll hope for the best on the other ones as I show you to do them. Okay? So here's the rules for a rotation of 90 degrees. So rotation, this is not a reflection, this was rotation of 90 degrees. Okay? Moving our x and y, you will see a change in those because your x and y will switch places and your y becomes negative. So these are just kind of general rules. You should start accumulating a pretty good list of reflections, rotations, etc. Next one's going to be a rotation of 180 degrees. That's a whole half circle there. 180 degrees to our x and y. Now, you might have suspected that a big opposite thing will happen, but it may not have been what you expected. It's negatives, not just flip-flop x and y. They actually just become all the way to the other side, and they are negatives, or opposites. Okay? Don't think they just become negative. They become opposite. So if they were negative to begin with, they'll become positive, and vice versa. Okay? 270 degrees is the next one. That's 180 plus 90, right? 270 degrees. When that happens to our x and y, they will flip-flop, but this time the x will become negative. Alright, there's your three easy ones. Those are the three easy ones. Now, if it says a rotation of 0 degrees, you didn't move anywhere, so that's why the next one doesn't make any sense. But the three easy ones are listed there. Let's do some examples. I'm going to give you an original. I'm just going to put it on the top right-hand side of my page and then put them next to each other. So here we go. If the original is 1, 2, and I'm rotating it 90 degrees, because I'm following this line here, okay? I'm rotating it 90 degrees. The answer is going to become 2, 1, and the front piece is going to be opposite. Questions? Next one. Then I'm going to put a -1, 2, and this one's going to be rotated 180 degrees. So they're going to flip, or sorry, they're going to just become opposites. So I'm going to rewrite them the same way and make them opposite. So this one was negative before, so it becomes positive, and this one was positive before, so it becomes negative. Questions? All right. Last one. 7, maybe? 7, -2. Alright, now these are going to flip-flop. So, you're going to have a 2 and a 7. Now it said your x is going to turn opposite. So if our x was 7 before, it's going to become a -7. And your y is going to stay the same. So since it was negative in the beginning, it's negative now. No, you're not swapping them both. You're swapping them, x's and y's, and you are changing your original x to an opposite. In this instance, it does. Any questions yet? Okay, that is my chart of quick and easy examples. All right. Moving on down, we are in the book now. I want to be 100% sure that y'all guys understand when we're talking about rotation in degrees. How many degrees are there in an entire rotation? 360, right? So if I was to start here, I'm just going to start on some point on my x-axis, and I was to go from here to there, how many degrees have I traveled? 90. Okay, now how many? Okay, now how many? Now how many? 360 or 0, right? Okay, so I'm going to write that down. So I start at 0 degrees, I went to 90 degrees, and 180 degrees, and then 270.
What did we do?
Because 90 plus 180 is 270. Because 90 plus 180 is 270. right? Each one of these is 90 degrees. And then y'all guys said that this could also be 360. So know that 360 degrees and 0 degrees in this instance, because you're going to arrive at the same place, is exactly the same. So 360 degrees is the same as 0 degrees. Now, if I told you what is negative 270 degrees, you're going to start at the same place, but you're going to go backwards 270 degrees. So look at what I do. Start here, 90, 180, negative 270. So really, negative 270 is the same as 90 degrees. I'm just going in the backwards direction. Okay? Any questions about that? Negative 360 would start here, go around negative 100 or 360. Oh, so negative 180 is the same as regular 180, right? Because watch, 90, 180. I just went in the negative direction. 180 and negative 180 are the exact same thing because you end up in the same exact spot. Now what if I said go negative 90? What is that equivalent to? Negative 90. Remember, I'm starting here and I go negative 90. So it's the same as positive 270. Negative 270 went 90, 180, and then 270, right? So negative 270 is the same as 90 degrees. So if you want to write that in, you can. 90 degrees is the same as negative 270. And 180 degrees is the same as negative 180 degrees. And 270 degrees is the same as negative 90 degrees. Okay, they're all pretty much equivalent. Everybody should know 90 degrees. Most of you should know 180 degrees. And everybody should know 360, right? Anybody that watches any kind of BMX or X Games style of stuff, that's pretty popular moves, is spinning a bunch of times. Alright. Moving on down. We're going to do the picture that's listed on the connections page. So the connections page shows this triangle. See if I can get it to show up on here a little better. So it shows that triangle right there, right? We have a G, H, and J. I'm not going to use the picture as much as I'm going to use these little cheat sheet that I got going on here. So I want to take G, H, and J, and I want to identify where they are on my graph. So I'm going to put you guys into groups. Group 1, you're going to have G. I want to know the coordinates of G. I want to know H, and I want to know J. Mark, you're going to verify J. Yes, sir. G, H, J. Mark, you got J. Okay, tell me the coordinates when I call on your group. You got a couple of seconds here. 10 of them. All right, group 1, what is G?
For 90 degrees?
No, just for the original. I want to know the original point. What is G?
Oh, 1, 2.
It's 1, comma 2. Boom. H, what is it?
4, 6.
You say it is 4, 6. I agree. And Mark, what is J? He says it is 5, 2. Do you concur?
Yes.
5, 2. Okay, now it says perform a rotation of 90 degrees. So I'm going to say rotate 90 degrees of this point right here. So I'm going to look at my little cheat sheet. I'm going to say it flips it and changes my y. Okay, so I'm going to flip it, change my y. So G, rotated 90 degrees, will be G prime. And yes, it'll be negative 2, 1. Cool? Oh, no. H rotated 90 degrees will be H1, and J rotated 90 degrees will be prime. So I'm going to flip it, so it becomes 6 and 4, and change the sign of my front piece. Again, flip it, it'll become 2, 5, and change the sign of my front piece. Any questions about it? Real easy to follow these rules. Now, rotating them literal on a drawing is kind of difficult, but after I find the points, I can plot them, and you will very easily see. that it was a rotation. Now, keep in mind, this says rotation of 90 degrees, but that's always just from the center, okay? That only works from the center. So if it's not from the center, it won't work. Say that again, I'm sorry.
They ever tell you like rotate 90 degrees from this part?
They shouldn't. Not for these quick kind of things. They may, and you might have to draw it, but you won't have to do it from here. All right, moving on down. What if it said, let's go ahead and rotate these babies. Rotate them 180 degrees. Okay, so I'm going to make this double prime. So G double prime, H double prime, and J double prime. So again, looking from the original. Okay, I got to look from the original here. So I'd go up to my chart. I'd say, okay, I just flip them and change the sign of both. So from 1, 2, it's going to be 2, comma 1, and make them both negative. It's going to be 6, 4, and make them both negative.
And then 2, 5, and make them both negative.
Man, he's so smart. There you go. That one's kind of easy, right? Flip them, change them. Flip them, change them. Levi's going to give us the next one as well. Well, he was so good at the last one. I'll let him just keep on rolling, right? So it says, flip them, change the sign of the front one, right? So I'm changing the X this time. So I'm going to name that one G 1, 2, 3 prime, H 1, 2, 3 prime, and J 1, 2, 3 prime. So G says, flip them.
Yes.
Did we do 180 right, guys? Look at it.
No, because you're not supposed to flip them.
Not supposed to flip them.
I knew.
Oh, on mine, on mine 270.
Not really, but I do it.
That's supposed to flip them on 180?
Don't you know you're supposed to question the teacher?
Okay,
Oh, that's two. That's two.
I'm confused.
I think not. I mean, the first one, trusting you guys, wasn't my fault. Like, I'll own up to this one, but the first one, I think that was y'all. Yeah. All right, here we go. Make sure you change that chart. We were just supposed to change the signs on both of that one, right? All right, going over here. We'll let Levi take over.
That's a mistake. He's going to leave it over.
So we're going to flip them, right, Levi?
Yes.
So we're going to change from 1, 2 to 2, 1, from 4, 6 to 6, 4,
Yes.
and 5, 2 to 2, 5, and then I'm going to change the sign of which one?
You have to change them in here. It wasn't negative.
Right, but which one? The front or the back?
That.
The back in this case, right? So I changed them. We good?
Exactly.
Awesome possum. All right. I'm trying to scroll here. Go ahead and move on to the next one.
What is that H1?
Sorry. Up. Good? Alrighty. Example A is where we're at. Example A says quadrilateral STUV is graphed on the coordinate plane. Transform the quadrilateral STUV using this function. Now, it doesn't really tell you what it's doing. It just says transform it using this function. And it says whatever's happening to this guy, they labeled it with something, it's called, it's a Roman thing, theta. Okay? So x comma y, and it's transforming it, saying it's just going to make the y negative and move it to the front and stick the x in the back. So it says use this transformation equation for STUV. So first of all, we need to identify the originals of STUV. So let's go ahead and do that. Group 1, you got S. Mark, you got T. Group 3, you got U. And group 4, you got V. Give me the coordinates of those. STUV. Group 1, give me S. Negative 2, 1. Mark, give me T.
1, 5.
He says 1, 5. I agree. You? 3, 5. 4, -1 for you. Good. All right, now we need to just perform this transformation on her. So it's going to just write this arrow for this one. Now I'm going to flip it, right? So my y is going to come to the front, and it's become changed, and the other one's going back. So -1, -2 in parentheses. If you don't put them in parentheses, I will not give you credit for them. Those are not points on a plane if you don't do it. All right, and again, I'm going to flip them and change the sign of the one in the front. So -5, 1. Next one's going to be kind of the same thing, -5, 3 though. And then the next one's going to be +1, 4. Okay, because it was a negative before, it turns positive. Any questions about it? Okay, mainly it's just learning how to read the way it's there for you. So this one's name is S prime. This one's name is, whoop, broken pencil, T prime, U prime, and V prime. Cool? Questions, comments, concerns? If y'all feel like I'm moving too fast, I'll slow down. If not, I'm good. I'm going to go ahead and let you work as much as possible. All right, example B. That was example A. Example B says this. Triangle BCD was rotated to form its image. Triangle B prime, C prime, D prime. Identify the transformation and write a function to describe it. So I want group 1 up there. You're going to find B, group 3, C, group 4, you're going to find D. Mark, you're on D as well. I want you to find D, or sorry, your letter and its prime image. Okay? So give me both of them when I call for you. So I want B, and then I want B prime from that group 1. Same thing with C and C prime. And D prime. All right, B, what you got for the first one?
Original is
-2, -5, good.
prime is
-5, 2. All right, let's first identify what's going on here. What happened? They definitely switched places, right? So they went from X, Y, right, to YX for sure. What else happened? Did anything else happen from this guy to this guy? Are they all the same sign? Did any of the signs change?
Yes.
Which ones? The negative on the 2, which was the X, right? So it went opposite. Everybody agree with this?
Yes.
Okay, let's see if it keeps happening. C.
3, -1 was its original,
3, -1 original.
and then the prime was -1, -3.
So again, they flipped, and this one changed signs. Okay. We see a pattern here. All right, D. You give me D, you give me D prime, Mark. 6, -3, and Mark? -3, -6. And again, it flipped and changed signs. So it says, what happened to this? So I'm going to go back to my chart. I want to see if it follows any of the rotations. It'd be fairly obvious if it was a reflection, right? You'd just be able to look at it and tell that it was just a direct reflection, but it doesn't look like it was. So I think it's a rotation. I'm going to look at it, see which one of those falls into the Y, -X. So looking at them, there's a rotation of 270 degrees. So I'd go back to answer my problem. I'd say rotation about the origin by 270 degrees. So it rotated about the origin by 270 degrees. Meaning it just from the original, right, came from the center of your graph. And that would be my answer. Bam. Any questions? Comments, concerns? All right. Your practice